This video is a tutorial on how to complete homework number 6. The first box for Monday are 4 equations that result in either one solution, no solution, or infinite solutions. So let's get started with number 1. The rational number 1.6 is going to multiply by x to get 1.6x. And 1.6 times 4, you're going to need a calculator probably to speed this up. 1.6 times 4 is 6.4. So we put a positive 6.4. And then we bring down the minus 0.48, we bring down the equal sign, and we bring down the solution. Now on the left side, I have 2 terms without a variable. So those are called like terms. So I leave the 1.6x alone, and I combine 6.4 minus 4.8. So 6.4 minus 4.8, 1.6. Positive 1.6. So I had to choose to put that positive sign there myself, not because that's what this sign is, but because the result of this was a positive 1.6. Bring down the equals, bring down my answer. So now I'm going to use the opposite operation. 1.6x. These are additive inverses, so they cancel out. Equals negative 21.6. And now I'm going to use another inverse operation. And I'll use my calculator to do this math. So the first number is the top of the division problem here. This is the top numerator of this fraction. So negative 21.6 divided by 1.6. And I get negative 13.5. Now that's a good looking answer, considering I had all those decimals to begin with. Now if you want to know if you're right, what you do is you take this answer, negative 13.5, and you substitute it in for this value of x right here. So I would put 1.6, which was the original question, and instead of an x plus 4, with all the rest of this problem, instead of an x plus 4, instead of an x, I'm going to place my answer, negative 13.5. And now if I'm going to use a calculator to solve this, I would, in this fancy calculator, I would just type it exactly how I see it. But on a scientific calculator without all this large screen, I would do negative 13.5 first, and then I would add 4, because that's what's inside parentheses, and you always do that first in the order of operations, right? PEMDAS. So I would do that first, and I would get my answer. Then I would multiply that answer by 1.6, and then after I press enter, I'll take that product and subtract 4.8 minus 4.8. And I do get negative 20, which is exactly what that said. So here, I'll erase this part. That was my check step. So moving on to question number 2. So it looks like I have a fraction here, 1/5. I'm going to multiply it by 5, and 1/5 times 10. Now if you want, you could use your calculator. The ones in our class have like a button that says ABC on it. This fancy graphing calculator that I have actually has it in the menu here. So I'm going to multiply 1/5 times the number 5. So if I didn't have a calculator, when you multiply a fraction times a whole number, you multiply only numerators. 1 times 5 is 5, and then you take that answer and you divide it by 5. So 1 times 5 is 5, and 5 divided by 5 is 1. So let's check that over here on our calculator. I got to go back and press the multiply sign here. 1/5 times 5 is 1. And now if I do it again for the second problem, 1/5 times This is a minus 10, so it's also known as a negative 10. So 1/5 times negative 10 is negative 2. So here, instead of writing 1/5 times 5x, I will just write the answer, which was 1. 1/5 times 5 was 1, and 1/5 times minus 10 was a minus 2. And now, since I only have 2 terms on each side, there's nothing to combine, so I'm going to use additive inverses here, or I'm going to use opposite operations. So I like to move my x's first, so I can find out if they're going to disappear on me, because then I would have a special answer. But it looks like 2x's minus 1x is 1x. So 1x, I'm going to leave the 1 invisible this time. 1x, you can leave the 1 invisible. And my final inverse operation would be minus 34 on both sides. And it looks like I get negative 36 is equal to x, and there's no dividing because dividing by 1 doesn't do anything, so I can just leave it like that. Again, if you want to check your answer, you take this value, you plug it into that x position. Alright, let's continue on here and move a little bit quicker with these next problems. So on these next problems, I have variables on both sides, so I'm going to choose to move this variable first because it's smaller, and I like to keep my x's positive. 11x plus 4 is equal to 24, and then I'm going to subtract 4 from both sides. 11x is equal to 20, and then I'm going to divide by 11 here, and let's see what I get on my calculator. If I get a pretty crazy number, 20 divided by 11, I get a repeater. Now I could certainly write this with a repeating bar, but I know that I usually tell you not to do that. So if you don't get a terminating decimal, you simply leave your answer in fraction form. You just don't do the math. You just leave it here the way that it is. I don't know why my pen's not working. So it would be 20 over 11. For some reason my pen doesn't want to write. Oh, there we go. Alright, so let's fix this here. There we go. So 20 over 11. You just leave it in fraction form. Okay, last one. 6 minus 2 times the quantity of 4x plus 1. So if you have parentheses, you have to distribute first. Do not do 4, 6 minus 2 is 4. Do not do that. That does not follow the order of operations. So you cannot do subtraction before you do multiplication. And multiplication here is what we would do to clear those parentheses, right? To clear those parentheses, we would use distribution, but my marker is not working. Trying to erase, but it's not working. Ah, there we go. Okay, let's try again. So, like I said, we're not going to do 6 minus 2, but we are going to distribute this minus 2, right? This minus 2 is important. Negative 2 times 4 and negative 2 times 1. So the 6 stays the same. Negative 2 times 4 is negative 8x, and negative 2 times 1 is minus 2, also known as negative 2. So now my left side seems to have 3 terms, so I'm going to combine like terms here. And 6 minus 2 is 4, and bring down the rest of my problem, which I have not used any of these pieces or terms yet. So now I'm going to move this 8x here. I'm going to move this 8x here. Whoops. I don't know how that changed colors on me. So 4 equals 13x plus 4. I don't know why it keeps changing colors. And then I'm going to subtract 4, and look at that. I get 2 cross-offs. So this one I'm going to leave blank. I'm not going to write that it's a 0. I'm just going to bring down my 13x. But over here I can't leave it blank. I actually have to write something because it's an empty side. So I have to write 0 here. And now when I divide by 13, I still get 0. And that's my answer. My answer is actually the number 0. Alright, let's take a look at the second box on the homework, which is graphing on the coordinate grid. And we are going to graph A first, and it does say that you need to graph on the grid, but it also says you need to label it. So from the origin, you move along the x-axis 2 units to the right and 3 units down. You create a point there, and you label it A. Letter B. 0 on the x-axis, 4 on the y-axis. So 0 on the x-axis means nowhere left or right, and 4 units up. So that would be B. C is -3, 5. So from the origin, 3 to the left, that's -3, and then 5 up. So that would be here. That's letter C. And now letter D is 0, 4. Oh, I did this one already. Alright, let's do letter E. -6, 0. So -5, -6, and 0 up or down. So that one's right there on the axis. And then letter F is 2 to the right, and -1, and 0.5 means halfway. Right there in the middle. Right there in the middle. We'll label that F. Alright, let's turn the paper over. Take a look at the back side. So we're going to solve some more equations here. Let's see. The most common mistake I see on a question like this is students that subtract 6a, and then they magically move the equal sign like this. Okay, the equal sign is here. It is not in front of the 18, so there's no way this could ever happen. There's no way. This can happen because then it keeps my constants and my variables on separate sides. So the final step, we get -9. Question number 12, I'm going to move the 6p, and it doesn't matter which p you move, but if I move the smaller one, my p will remain positive. Now my handwriting is getting a little messy because my pen broke, so now I have to use my finger. Alright, let's see. So I subtract 5 from both sides. 7p was equal to -8. And then I divide by 7 on both sides. And it looks like I get -8 divided by 7 is probably going to be some wacky number. Let's see. -8 divided by 7. Yeah, that's a pretty long number. I think it might start to repeat here. 1, 4, 2. I think it's writing a 3 instead of a 2 because I think it ran out of space, so the 8 rounded this up, but it definitely is a repeater. Now I know this is a repeating decimal because this is a fraction, and all fractions are rational, so it has to eventually repeat. But I'm not going to write the decimal form because it's so long, so I leave it as a fraction, just like that. Okay, let's take a look at question 13 here. So this one has some scary looking fractions in it, but the steps are always the same. The variable terms need to be together on the same side. The constant terms need to be together on the other side, and it doesn't matter which side they're on. Variables to the left or variables to the right, just as long as they're together. It looks like I have a 1/5 W and a 3/10 W. Now certainly in order to combine like terms you need common denominators, but since we're using calculators now, we don't even need to bother with that. So I think I'm going to add 1/5 to both sides. This way, my fraction will stay positive. My coefficient will stay positive. So I'm going to add 1/5 W to both sides. My left-hand side, only a 4 is left. And now over here I have 3/10 W plus 1/5. Now, I know already that 1/5 is the same as 2/10. So I'm going to have 3/10 plus 2/10, which will give me 5/10, or 1/2. But if you don't know, simply take your calculator. Maybe you're going to use the online Desmos scientific calculator here. Click this fraction button and type 3/10, and then next to it, you're going to add 1/5. Right? Now, I know that it gives you an answer in fraction in decimal form, but if the question starts in fraction form, you should finish it and continue it in fraction form. So I'm going to press this button over here to convert it back to a fraction. So just like I said before, the answer will be 1/2. So 3/10 W plus 1/5 W is 1/2 W. And don't forget about that minus 9 at the end. So now what I'm going to do is I'm going to add 9 to both sides so that my constants will be on the other side of the equation. That's going to leave me with 9 plus 4, which is 13. And now I know that 1/2 is a coefficient, and you might want to divide by 1/2, but we don't divide by fractions. So if you want to divide by a fraction, you simply multiply by the reciprocal, right? Multiply by the reciprocal. So 2 times 13 is 26. And 1/2 W times 2 over 1 is just going to be 2 over 2, which is the same as 1. All right. Numbers 14 and 15. They're getting a little bit longer here, but we can certainly do these problems quickly. Negative 12y plus 15 stays the same. Negative 2 is distributed. We get negative 16y, and be very careful here. Negative 2 times a minus 3 is a positive 6. So I'm going to combine like terms over here on the right. I'm going to keep the left the same. Let's see, I'm going to get negative 12y plus 6. And now I'm going to add 12y to both sides. And it looks like I get a double cancellation here, right? And let's see what's left over. Do the numbers that are left over, do they make a true sentence? No. So if that is not a true sentence, no, then it is no solution. No number would work to plug into y to make this sentence true. Okay, last one. 6 times 3 is 18x. 6 times minus 5 is minus 30. And you bring down the rest of that side. Now over here we're going to distribute. We're going to get 15x minus 30. And now over here we're going to combine like terms. We're going to get 15x minus 30. And rewrite this other side, 15x minus 30. Now some of you may be seeing it already. We have an identity here, or we have a case where the left side and the right side exactly match. And when you have that identity, you have a special solution, right? You have a special solution. So let's see, let's prove it. Let's prove that if the variable disappears, I forgot, okay, let me see, there we go. We get a negative 30 equals a negative 30, and that is true. That's a true sentence. Or see, this one over here was false. So a true sentence is infinite solutions. Okay, let's take a look at the final box, which is a graph. And the graph requires labels, and it requires a scale here. So let's see what the range is that we have to start and end with. So it looks like my days, that's my independent value, goes from 2 to 10, so I think I have to go by ones. And I'll just make it. and the total number of hours studied. So total hours studied, that's our title. Whoops. And it looks like my scale is 3, 7.5, 9, 15. 7.5 is awkward, but I have to go all the way up to 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So going by ones won't work. Now I can certainly go by twos, but look at my numbers. None of them are even. So going by twos isn't really a good idea. Why don't I go by threes? Let's see what happens if I go by threes. So I would have a 3, I would have a 6, I would have a 9, I'd have a 12, I'd have a 15. Well, that's certainly big enough here, right? Because I need to get up to 15, which I did. So let's give this a graph here. So on day 2, total hours of study was 3. That's a nice corner point. On day 5, the total hours was 7.5. Well, let's see. 6 and 9, so I know it's going to be in between here. But 6 plus 1.5, that would be 7.5. And 7.5 plus 1.5, that would be 9. So I guess we're halfway between. There we go. And then after 6 days, it's 9 hours. And then after 10 days, it's 15 hours. And if we did this right, we should have a nice, linear, straight line graph. So I constructed it, I labeled it, and it definitely made a line. And that is how you complete homework number 6.